Hello everybody, and as promised we're going to do another video talking about the role of the nucleophile. And for that I'm just going to give us one substrate. Here we're going to talk about R2 iodo butane, not the substrate. We're going to talk about the nucleophile, and then we're going to talk a little bit, we will talk a little bit about the substrate when we talk about, I'm going to do a little bit of an introduction for SN1 reactions. So we talked about here our iodine, that's our leaving group, and we know that's a really good leaving group, right? HI, strongest acid, very good leaving group. So now, if I look and I have NaOH, lithium OCH3, and then I'm going to put a couple other things here. In green, we're going to have water, and here I'll have methanol. Okay, so we're talking about the strength of our nucleophile. And remember, to be a nucleophile, you have to have a lot of electron density. And if you notice, our ones in blue are our strong nucleophiles. To be a strong nucleophile, you have to be a stronger base. Meaning your conjugate acid would be weaker. So if I'm looking, remember, NaOH is actually Na plus OH minus. So this minus piece here, this is your nucleophile. The sodium is not part of the nucleophile. Just as here, lithium plus OCH3 minus, this is my nucleophile piece. And if I look and I react with these two, right, these are both strong bases, I can have, remember we're going to flip our stereo center. Here I would have the OH from this one, and with this one, okay, so we can see that these are strong nucleophiles. If we look at our other two, we have water and methanol. They're nucleophilic, but they're not strong nucleophiles. They're not strong bases. So because this is equally initiated by my nucleophile and my leaving group, having a weak nucleophile makes it much less likely. So these are much less likely to react to, we'll put react here, react via SN2. Because remember, it's a bimolecular, meaning I need a strong nucleophile and a good leaving group. So that's kind of, as we start looking, that's one of the things we're going to start looking at. All of our reactions, we have a substrate, a leaving group, and a nucleophile. So SN2, I'm just going to say SN2 needs a good leaving group. Group, did I put an R there? Yes, I did. Group, and it also needs a good nucleophile. So now I also want to talk about the role of the substrate, and we're going to talk about that on the next video. We'll talk also a little bit about SN1 reactions. But if we look, and we'll just do the same substrate, we're going to have CH3I, and it's going to react with plus CH3O minus. This is very quickly going to react to form CH3OCH3. So that's going to form an ether. If I have, and right, this is a methyl. If I have boom, boom, I, and I'm going to react it with the exact same, plus CH3O minus, or I could put a sodium there if I wanted to. I would also see this will very quickly go to OCH3. So my methyl is fast. Primary is also fast. Secondary, if I look here, and I put my iodide here, and this time I'm just going to do NaOCH2CH3. I'll use the ethoxide. This will go slower, but it will still go forward to let me do that in blue, OCH2CH3. If I make it, this is going to be slower. This is a secondary, and it's going to be slower, but still forward. Once I have a tertiary, so I'm just going to put a methyl here and my iodide here. It will not go forward for SN2. So if I treat it with my base, it's not going to go forward. So if I treat it with just say NaOH, nothing's going to happen via SN2. Something will happen, and on the next video, we will talk about what will happen. But I do want to kind of bring to you that idea of, because the nucleophile in each of these cases is coming in, if I have steric hindrance, that's going to make it more difficult for the nucleophile to attack, if there's no space for that to come in. So methyl is the fastest, then primary, then secondary, and tertiary for SN2 will not react. Next video, we will talk about introduction to SN1.